In the summer of 1983, an asbestos worker named Frank Garcia walked into a commercial shell pit near Ruskin, Florida. He wasn't looking for buried treasure. He wasn't searching for a lost civilization. He was looking for fossils. The pit was being mined for something far less glamorous, crushed seashells used in construction and road building. But somewhere inside that ordinary industrial landscape, Garcia noticed something unusual: bones. And not just one or two. There were fossils scattered through the sediments in numbers that were difficult to explain. Garcia was a self-taught paleontologist, and he knew enough to realize that this wasn't an ordinary fossil find. So he started digging. Then he contacted the Florida Museum of Natural History. What happened next would turn an industrial shell mine into one of the most important fossil sites ever discovered in Florida. Because when scientists finally began excavating the site systematically, they didn't find a handful of fossils. They recovered more than 20,000 identifiable specimens. And the strangest part wasn't the number. It was what those fossils represented. Because buried in this Florida shell pit was an entire lost ecosystem, one that had existed roughly 1 million years ago. And once scientists began putting the pieces together, the pit started telling a story about giant mammals, saber-toothed cats, ancient rivers, sharks, and a Florida that looked nothing like the one we know today. The place was called the Lisey Shell Pit, and at first glance, there was almost nothing remarkable about it. It was located in Hillsborough County, roughly 7 kilometers southwest of Ruskin, and less than a kilometer from Tampa Bay. The Lisey Company was mining enormous deposits of ancient shells. For the people working there, the material was useful. For paleontologists, however, it was something else entirely. It was a time capsule. The fossils came from layers associated mainly with the early Pleistocene, roughly between 1.5 and 1 million years ago. That's important because this was a period when North America was already home to animals that would seem completely alien to anyone walking through Florida today. Mammoths, giant ground sloths, ancient horses, camels, tapirs, huge predators, and even enormous marine animals. But nobody knew just how much was hidden underground. Not yet. Garcia had discovered the site in July 1983. He and several friends began excavating it themselves. By late that year, Garcia had contacted David Webb, a curator at the Florida Museum of Natural History. Garcia even donated about 1,200 specimens to the museum. That number alone would have been remarkable. But to Webb and the museum researchers, it raised a much bigger question. If Garcia had recovered 1,200 specimens while working informally, how much was actually down there? The answer would soon become almost overwhelming. The museum reached an agreement with the mine owners and Garcia to begin a major excavation. On April 1st, 1984, the serious work began. And this time, they weren't simply digging wherever fossils appeared. The site was carefully divided into a grid. Researchers recorded where specimens came from. They collected sediment for screen washing. They documented the position of fossils and the geological context surrounding them. And they brought in an unexpected workforce. Volunteers. Hundreds of people from the Tampa Bay area helped museum staff and paleontology students excavate the site. The excavation continued until September. 6 months. One fossil after another. And the collection kept growing. But then something became obvious. This wasn't simply a place where a few animals had died. The site contained an extraordinary mixture of life. Scientists eventually identified at least 203 species from the broader Lisey shell pit fauna. That included sharks, bony fish, amphibians, reptiles, birds, and dozens of species of mammals. Think about what that means. A single fossil site was preserving evidence from an entire community, not just the predators, not just the large herbivores, but the animals living in the water, the animals moving through the surrounding landscape, and the creatures hunting them. It was almost like someone had taken a snapshot of an ancient Florida ecosystem and buried it underground. And then came the animals that made the discovery famous. One of them was a saber-toothed cat. Not the exact species most people picture when they hear the words saber-toothed tiger. This was Smilodon gracilis, a smaller and more primitive relative of the better-known Smilodon species that appeared later. The Liese site produced an unusually large sample of these cats, and that mattered because fossils don't just tell us what animals existed. They can tell us how those animals lived. Their teeth, their bones, the damage on their remains. Even the way their fossils are scattered can provide clues. But the saber-toothed cat was only one piece of the puzzle. There were also giant tapirs, ancient camels, horses, ground sloths, peccaries, a primitive mammoth, and a short-faced bear. One of the strangest creatures was Paleolama mirifica, an extinct camelid. Yes, camels once lived in Florida, and they weren't the only animals that would seem out of place today. The site also contained fossils of giant ground sloths and ancient horses. The landscape was becoming harder and harder to recognize as Florida. But the surprises weren't finished, because when researchers examined the smaller fossils, they found another world. Fish, sharks, rays, small reptiles, birds, tiny mammals. Some of the marine material was especially important. The combined fish fauna from the Liese sites included 73 species, including 23 species of sharks and rays. According to the scientific study, it was the largest fossil fish fauna ever reported from the Cenozoic of Florida. That meant the site wasn't simply preserving animals that lived on land. It was also recording the ancient waters surrounding them. And this created a fascinating problem. How did all of these animals end up together? Because the fossil bed wasn't simply an ancient cemetery where everything had dropped in one place. Researchers studying the geology found that the fossil-bearing material occurred in relatively thin layers within much thicker deposits of marine shell beds. The bones were mixed with evidence of marine, freshwater, and terrestrial environments. So scientists had to reconstruct not just the animals, but the landscape that brought them together. And that's where the story gets even more interesting. The Liese Shell Pit was not a dry Florida landscape covered in trees and houses. The geological evidence indicates that these deposits formed in an environment connected to water. The remains of terrestrial animals could be transported into an estuarine setting. Imagine an ancient landscape where animals moved across the surrounding land, while rivers, wetlands, and coastal waters carried sediment and remains toward a larger body of water. Over time, those layers accumulated. Then more sediment covered them. Then more. For hundreds of thousands of years, the evidence disappeared beneath the ground, until people began mining the shell deposits and accidentally opened the archive. But there was another mystery. If these fossils were around 1 million years old, how could scientists determine their age? You can't simply look at a fossil and read its birthday. Researchers had to combine different forms of evidence. They used the fossils themselves. They examined the surrounding geology. They compared the animals with other fossil communities. They used magnetostratigraphy. They also used isotope-based methods. Together, these lines of evidence helped place the main Liese fauna within the early Pleistocene, roughly 1.6 to 1.0 million years ago, with the major fauna generally associated with the later part of that interval. And that date creates a strange picture. Because around this time, Florida wasn't an isolated biological world. Animals were moving across North America. Species that had evolved in different regions were appearing in new environments. Some of the animals at Liese were part of the great biological exchange that reshaped the Americas. The fossil record at the site contains evidence of this mixing. And because the collection was so large, researchers could study it at a scale that smaller fossil sites simply couldn't provide. That's one reason Liese became so important. It wasn't just a pile of old bones. It was a database of an ecosystem. And every fossil added another line to the story. But there was still a problem. The fossils weren't lying neatly in complete skeletons. At Liese Shell Pit 1A, no skeletons were found fully articulated. Instead, isolated remains were common, with scattered associated skeletons also present. That made the researchers' job much harder. A bone lying beside another bone doesn't automatically mean they belong to the same animal. The scientists had to determine how the remains had been transported, broken apart, buried, and preserved. This field of investigation is called taphonomy. And at Liese, it became essential, because understanding how the fossils were deposited was just as important as identifying them. The bones weren't merely telling scientists what lived there. They were also telling them what happened after those animals died. Then there was the predator question. Among the carnivores, the saber-toothed cat Smilodon gracilis was particularly abundant. Scientists could examine the bones of its potential prey and look for patterns of damage. That doesn't mean every mark automatically reveals a dramatic hunt. In paleontology, the evidence has to be interpreted carefully. A broken bone could result from a predator. It could happen during transport. It could happen after burial. Or it could be caused by other animals. The point is that the site preserved enough material to investigate these questions scientifically. And that is what made the Liese discovery so valuable. There were enough pieces to test ideas rather than simply speculate. By now, the original discovery had grown far beyond Frank Garcia's first fossils. The local shell mine had become a major scientific site. The community became involved. News organizations began paying attention. Volunteers helped excavate. And the Florida Museum gained an enormous collection that researchers could continue studying for decades. The discovery even changed something beyond paleontology. It demonstrated the power of public participation in fossil excavation. Before Liese, fossil collecting at many museums was largely the work of museum staff and graduate students. But the sheer size of the Liese excavation made that approach impractical. There were simply too many fossils. So volunteers became part of the solution. And that experience helped establish a model that would later be used at other fossil sites. There is an almost perfect irony in that. The discovery began with an amateur fossil hunter. Then professional scientists became involved. Then hundreds of ordinary people helped excavate. And together, they recovered evidence that professional researchers alone might have struggled to collect quickly enough. The shell pit had become a scientific excavation powered by an entire community, and the number kept climbing. Today, Florida Museum records list Liese Shell Pit 1A among the state's largest vertebrate fossil sites, with tens of thousands of cataloged specimens. One museum comparison lists more than 45,000 specimens for Liese 1A. But perhaps the most remarkable part of the story is what those numbers actually represent. 40,000 specimens aren't 40,000 stories. They're fragments, teeth, jaws, vertebrae, scales, bones, shells, tiny pieces that on their own might look almost meaningless. But when thousands of them are placed together, patterns begin to appear. A predator, a prey animal, a river, a shoreline, a changing climate, a migration, an ecosystem. A moment in Earth's history that disappeared long before humans could witness it. That's what the Liese Shell Pit really preserved. Not just fossils, a world. And perhaps that's why the original discovery still feels so strange. Frank Garcia wasn't standing in a museum when he found it. He wasn't working at some famous archaeological site. He was in a commercial shell pit near Tampa, a place built for extracting material from the ground. And the deeper people dug, the more obvious it became that the ground wasn't empty. It was full of history. History that had survived for roughly 1 million years, waiting beneath layers of shell and sediment. The first bones Garcia noticed seemed like an interesting find. Then there were hundreds, then thousands, and eventually more than 20,000 identifiable specimens from the major excavation, representing an ancient community of at least 203 kinds of animals across the broader Liese fauna. The shell pit that once existed for roads and construction materials had accidentally become a window into prehistoric Florida. And somewhere beneath that ordinary landscape were the remains of animals that would have seemed impossible there today. A saber-toothed cat moving through the ancient landscape, camels crossing Florida, ground sloths feeding nearby, mammoths appearing on the horizon, and sharks swimming through waters connected to the same ancient environment. None of them knew they were preserving a story. They were simply living. Then they disappeared. The sediments closed over them. Millions of years passed. And finally, in 1983, an amateur fossil hunter noticed something that everyone else had overlooked. A bone in a shell pit. That single observation led to one of the richest fossil discoveries in Florida. And the strangest thing about it may be this: the fossils were never really lost. They had been there the whole time. We just hadn't dug deep enough to find them. If you enjoy stories where an ordinary place turns out to be hiding an extraordinary past, subscribe for more. Because sometimes, the most incredible discoveries aren't waiting in some distant wilderness. They're buried underneath the places people have been walking past for generations.